All right, that should now work, hopefully. Let's see what's happening. Rossi Bop. One person gone, brilliant. Fucking language. Can't be swearing, that's not good luck. Flipping hell. I'm gonna watch out for that and start teaching again. Yeah, man. Let's see. All right, hello. Hope people are doing well over there. Perhaps they're on, perhaps they aren't. We shall see. Seem to have two people on. Who's the other person? Who would have logically thought it'd be Naman, but you can't assume these things, unfortunately. So, Naman, if you are on, say hello. And then we'll start. All right. Hello, good to see you. Right, okay. So let's just quickly recap what we're doing. We're doing something called simultaneous equations, right? Here we are. So simultaneous equations. Now, the simultaneous equations we did, can you remember how many answers we get from them? So write it in the chat box. How many answers do you get from simultaneous equations, the ones that we did? Yeah, and that's what makes simultaneous equations special. For quadratic equations, you can get x1, x2, but for simultaneous equations, you get x and y, or a and b, or whatever. So just to prove the point, it doesn't have to be x and y, it's just going to be two different letters. I want you to solve this equation for me, which is a plus b equals 10, and a minus b equals 2. All right, so I need you to solve those and find a and b for me. Very, very simple set of equations to deal with. Just to warm up. A is 6, B is 4. That seems to work for me very nicely. Brilliant, brilliant, brilliant. All right, slightly harder one this time. Good job, good job. So 2a plus 3b equals 9. 2a minus b equals, let's say 1. Okay, so solve that one for me. In fact, Make that, no, keep that as it is. So this one's a little bit harder. In fact, can I change that? Let me change that because I want to kind of show that trick. So how about a minus 3b equals 6, all right? So here you've got 2a plus 3b equals 9, a minus 3b equals 6. And if you hadn't noticed, I did change it up because I don't want to go too far too fast. That's what this isn't. Right, you don't understand that one? Okay, cool. So here we've got the 3b and the 3b. So we can just add them together to cancel them completely. So what you'll end up having is add these two guys together. You get 2a plus a is 3a. 3b plus minus 3b is just 0. So you get 3a equals 15 and a equals 5. If a equals 5, then 5 minus 3b equals 6. Yeah, 5 minus 3b equals 6. So b equals negative a third. All right, I'll move the camera so you can see that slightly more clearly. Now, which step of that would you find confusing? Possibly that one, because I've just gone, well, the a, so a equals 5, I've just put it into that equation. I put it into equation number 2. So if a is 5, that means 5 minus 3b equals 6, yeah? If 5 minus 3b equals 6, then I solve that equation. Do you need to see that done, yes or no? Where I'm putting my finger, do you need to see this line to that line explained? Yes or no? Yes or no? So it's this one I'm talking about. Do you need to see this turned into that? You understand it, good. What about you, Numan? Do you understand how you get from here to there? So from 5 minus 3b equals 6 to b equals negative a third. You understand it? Okay, good. X. Let's do another one just to be sure. Do another one just to be sure. So here we've got 2a plus 6b. Is that yes that you want to see it done? Or is that yes that you understand? Bit of clarification, anyone? It looks like everyone's dropped off the thing as well. So you guys put, yes, fine line. Okay, so it was something on the lines of 5 minus 3b equals 6, yeah? Harris, you can look at that question while you're waiting. So here's how you deal with that. Take away 5 from both sides, and you get minus 3b. 6 minus 5 is 1. Divide both sides by minus 3, and you've got b equals minus 1/3. There you go. All right, fastest way of doing it. There are other ways, but that's probably the quickest way of taking you from where you want to go to where you want to be. So 5 minus 3b equals 6 was the starting point. You move the 5 onto the other side by subtracting 5s, yeah? You take away 5 from both sides. And you end up with minus 3b equals 6 minus 5, which is just 1. I hope that's making sense. Excellent. So can you try the one directly above it? So as far as that's going to be answered. Right. So have a look at the question directly above it. It's very, very similar in style. Right, so A is what? You're subtracting. I disagree very strongly on that one, my dude. Try that one again. Certainly not 4 point. It's not 4 point anything. Straight up, it's not 4 point anything. It's not 6. Well, 6, no. Actually, hold on a minute. No, not 6 or 8 thirds. In a minute, I'm going to explain. I'm going to actually go through this one. Because the mistakes you're making are showing you don't understand. Again, there's nothing to do with 8 thirds or anything like that. Just stop now, all right? Watch me just stop, right? What we need to do is get rid of one of the letters. Here we've got 2 pluses. So the only way we can cancel these out is by subtracting from each other. How do we know what to do? 6b minus 6b equals 0. That's what tells us what to do. We need to look at the question and think. Don't just follow blindly a rule, yeah? Before we subtracted, because subtracting would make the b's cancel. Here we're going to, so before we added, because that would make the b's cancel. Now we're subtracting, because that's what makes the b's cancel. We're not trying to learn rules here. We're not trying to learn rules at all. What we're trying to do is figure out what we're going to do to make 2 letters become 1 letter. And we have to think every single time. So if you're thinking, oh, I'll just take away every single time, half the time you'll get the question wrong. And in fact, more than half, because the questions are going to get harder. All right. So what you need to do for every single question is think, okay, I've got a plus 6b and there's plus 6b there. If I turn it into 6b minus 6b, then that's going to be no b's. I don't need to worry about b at all. That's what the thinking you need to have for these questions is. All right. So let's go over this. 2a minus a is 1a. Yeah. 6b minus plus 6b is just going to be minus 6b. 6b minus 6b is 0. And then a is minus 6. Yeah. Now we've got a is minus 6. Looking at a is minus 6, you substitute into whichever equation you like. You've got minus 6 plus 6b equals 10. 6b equals 16. Looks like I owe Harrison an apology. My apology. You did actually get it right. That's me jumping to conclusions there. That seems correct to me. Put that on the other side. You're going to get b equals positive 8 thirds. Looks like. So you weren't correct in the b, but you were correct in the a. So I should have made that clearer. But that's now done correctly. All right, let me just, again, move it down so you can see it a little bit easier. So again, it's all about adding 6 to both sides. You get 6b equals 16. Divide through by 6. 16 over 6 is 8 thirds. The most important thing you need to walk away with is that sometimes you're adding and sometimes you're subtracting. And a quick way of remembering it is if the signs are same, subtract. And if the signs are different, add. So here the 2 6b's are both positive, so subtract. But really just look at it and try and understand it rather than memorizing rules, because that's going to mess you up in the long run. Because there's a lot of times in maths where you just can't memorize a rule, you just get killed. And if you're thinking, oh, I can just memorize the rule, then you will end up making those mistakes over and over again. Just remember how quadratics was. Yeah? So in your head, get this clear now. I'm trying to kill a letter. How am I going to kill that letter? How do you get minus 6 and not plus 6? Because 4 minus 10 is minus 6. 4 minus 10 is minus 6, my dude. It's not 10 minus 4, it's 4 minus 10. Do you understand that? Right, so we're going to do, again, try this until we're getting strong at it. It can be the other way around, but then you have to turn the equations upside down. Right, so let's try another similar one. So we've got 3x plus y equals 15. 2x, let's go with minus y equals 8. All right, so you've got 2 of them there. So claim first one is x equals 7. Good. Got x equals 7. That's a good start. Y equals minus 6, correct. That's the one, right? In fact, actually, y is 6, not minus 6. Let me show you why. So I agree with you, x equals 7. That's 14 minus y equals 8. So y has to be 6 because 14 minus 6 equals 8. If y was minus 6, which is wrong, the minus and the minus will become a plus, and you get 14 plus 6 equals 8, which is not true. So it's not minus 6. It is positive 6. All right? I hope that makes sense. That was done reasonably well. Well done, man. All right. I'll give Harris a second just to catch up. But the top equation, what about the top equation? Oh, if you put it in the top equation, doesn't make a slight bit of difference. You've got 3x plus 6 equals 15. Now, hold on a minute. What have you got x as? Sorry. Your x is 7, isn't it? Sorry, my apologies. So you've got 21 plus y equals 15. Yeah? So y has to be minus 6. I'm sorry, y has... Yeah, you're right. Hold on a minute. What the hell happened there? There's a shout. Let's find out what's happened here. So you've got... Yeah, well, okay, fair enough. That's 21. Why is that behaving like that? Have you got that question right? Let's just check it. Do the subtraction. Or have you meant to add them? You meant to... Oh, I see what your mistake is. No, there's been a mistake the whole way through. No, this is definitely wrong. Let's do this together. Right. These signs are different, so you add them. 3x plus 2x is 5x. Y minus... This will all cancel. So again, it's trying to get rid of these things together. If you put a minus here, if you try to subtract, yeah, the minus and the minus will make a plus. You get plus 2y. So you should have added the two equations to get 5x equals 23. X is 23 over 5. That's why there's a mistake in the question. All right? That's why it's wrong. Follow that. Again, you're making the mistake on the same point, which is what to do about adding and subtracting. What have I told you? There are two ways of thinking about it. Number one is the one that you must do, which is to just literally think about it. If I subtract these from each other, I get y minus minus y. That's plus 2y. All right. So every time, start your thinking, looking at the equation by going, okay, what do I need to do here? Do I need to add or do I need to subtract? Right? And make the right choice early on. That way your question won't go wrong. All right. So that's the method I want you to look at. Every time you start this question, what should I do? If you add these guys together, I'll write down what would happen if you add these guys together. You get y plus minus y. And you know a plus and a minus just makes a minus. Y minus y is 0. That's perfect. So adding is the right shout here. That's what you need to be thinking about each time. If you don't think about these things, you will get it wrong 50% of the time because you'll pick the wrong one. All right? Once you've got x equals 23 over 5, you can substitute into your equations. I'd like you to do that because that's quite challenging fractions. I reckon you can do it, but it's challenging. So have a go at that. Right, so can you find for me, now you know what x is, can you find for me what y is? Okay, what's the answer? So we've got x, what's y? Six over 5, let's try it. So if x is 23 over 5, I'm going to put it in the second formula just because it's slightly easier. So x is 23 over 5, let's just pop that there. So you both agree it's 1.2, let's find out. Numan, I've warned you about using decimals already, all right? Please stop. You're losing out valuable practice of fraction skills, which you need. There's no point. And if you're using a calculator, absolute disgrace. Kill yourself now. The answer is 6 over 5, well done. Okay, you need to get good at fractions. One of your papers is non-calculator, right? So get in the habit of manipulating and doing calculations with fractions, all right? Okay, cool. Let's do another one. So your main task here for this question is working out, should you, in fact, no, not that one yet. Do you need to subtract these guys? do you need to add these guys and then solve the equation? So that's the first thing you need to think about straight away. How am I going to cancel? How am I going to cancel to get rid of one of the letters here? How am I going to cancel? Do I need to add the equations together? Do I need to subtract the equations together? All right. And then that's your starting point. All right. So first claim is x equals 3. I think I agree with that. Yep. Subtract is the right call here. So both 3? Yep. Yeah. Last one of these in this style, then it's going to get a little bit harder. So we've got 2x plus 7y equals 15. And then we've got 2x minus 7y equals how should I do this? Let's go with 6. It's a bit of a challenging one, but it's in the same style. It's in the same style. If I don't make this like, nah, leave it. It's going to come as fractions, but I wouldn't practice with fractions anyway. (21/4 is x. So we did a what? If that's going to be true, what have you done? You've added them, hopefully. So you're going to get 4x is 21. Yep, that's fine. Mm-hmm. 1 second, I'll just check that for you. Glorious. All right, let's have a quick look. So claim was, you add them together, of course they work. That's 1/4. 21/4, so that will go, let's put it in this one. Put it in the top one this time. So 21/4, so that's what, 42/4 here, plus 7y equals 60/4. 18/7. So 7y is what? Yeah, so 7y is going to be what? 18/4. So 18/28. And that divides through by, so it's 9/14. Yes, good, 9/14. Well done. Good job. Right, okay. Let's try something slightly different. It's not much harder, actually. Mathematics isn't really very different. So let's have a look at this equation here. What's different? Pop in the chat box. What's different about these two equations to all the other equations you've done before? What makes this pair of simultaneous equations? Yeah, that's right. Well done, Harris. You got it right. What makes these two equations different? No, that's right. What? Where did the box come from? Both 3x. Yeah? So here, it's not the y's that are going to cancel. It's the x's are going to cancel because the x's are the ones that are the same. How would you cancel them? Would you plus them or would you minus them? So you've got 3x and a 3x. How would you cancel the x's? Plus or minus? So you think you're going to add them. What's 3x plus 3x? Is it 0x or is it 6x? It's definitely not going to be adding here, is it? If you think about it, you want to get rid of the x's. Adding 3x to 3x is not going to get rid of anything. In fact, you're going to double your problem. You used to have 3x, now you've got 6x. Yeah, exactly. You see the problem there. You want to get rid of the x's, not the y's. How are you going to get rid of the x's? By subtraction, not by addition. You need to think about the question every single time. It's not y I'm trying to get rid of here. I'm trying to get rid of x this time. So the only way I can kill a 3x is to minus a 3x, to put a minus sign here. All right? Yeah, well, the x doesn't equal 0 necessarily. We'll find out in a minute, right? Might do. I haven't done the question yet. But what you need to understand is if you're cancelling the x's, you need to put a sign here, a plus or a minus, that makes this column equal 0, right? And adding would not have been the 1. Because if you put a plus there, you'd have gone 3x plus 3x equals 6x. And that would not have helped you in any way, shape, or form. So you need to put a minus sign there. All right. So when you're canceling the x's instead of the y's, you need to put a sign there that make the x's vanish. That's the kind of thing you need to learn here. Again, it's about thinking every single time, not just trying to follow a rule here. Yeah. You're trying to kill x, not y. So you don't do the same things that made you successful in y. You change up your path to see what's going to make me successful with the x's. All right. So when you're thinking about canceling the x's, look what cancels the x's. When you're thinking about canceling the y's, look what cancels the y's. All right. That's the logic behind it. It's not just a bunch of rules to memorize. You know what I'm trying to say on that? So we're going to subtract these. Let me do this one as an example. I'm going to work through this one with you. So you're going to take away, because 3x minus 3x equals 0. That's blessed. Y minus minus 2y. So a minus and a minus make a plus. So therefore 3y. All right. 10 minus 4 is 6. So we know y equals 2. All right. Nice and easy. Once we've got y equals 2, yeah? Once we've got y equals 2, then we can find x very easily, yeah? We'll put it in the first equation. We'll get that 3x plus 2 equals 10. 3x equals 8. X equals 8/3. Game over. All right? Nice and simple. That's how it works. The most important thing is you decide which letter you're going to be cancelling. Believe me, this will get worse. Which letter are you cancelling? And then what do you need to do to make it completely disappear? The whole point of simultaneous equations is you've got two equations with two unknowns, two letters, and you want to turn it to one equation with one letter. Yeah? Just keep that in mind. That is your focus of what you're doing. And it doesn't matter whether you're going the x or the y, but you've got to do the thing that does cancel the x or the y. All right? So I'll give you a minute to write that one down, including try and write down some understanding. Why am I cancelling x here? Because they're the same. So how do I do it? By subtracting the 3x. Because 3x minus 3x is 0. And if I put a plus there, I get 3x plus 3. If I did a plus there, I get 6x minus y equals 14. I'd end up with an equation with two unknowns and one letter, which is the absolute worst thing that could happen to you. Because it means you couldn't answer the question. So I'm going to give you about another minute or so to copy this one down. Get it copied down. Write down some notes on why and how this has happened. Right, so let's try another one. So this time, have a look at the equation. Decide which letters are you going to be cancelling. Is it going to be X's or Y's? And solve that equation for me. All right. So we've got X equals 5. That's totally wrong. It's totally wrong. Y equals 5. I mean, you can just see that Y equals 5 from there. That's nicely done. Y equals 5. That's done right, yeah. So if Y equals 5, what's X? X5, yep, good job. Another one. Bit harder this time. So claim is Y equals 2. That's right, it is. Y definitely does equal 2. Good job. And X equals 5.5. Well, that does look right to me. Yep, looks good. Well done, Nima. Nice one, nice one. Y equals 2. Yep, cool. Looks like with that one, that's getting sorted pretty well. That's nice. That's nice. Couple more of these just to make sure we've got this locked down. Okay, so we've got another one there now. But one more. If you get this one right, we'll do one more of this and I'll show you the next thing. So claim is that x equals 2. Yeah, 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 yeah. And y equals 4.5. Well, I think that's right. Good job. Okay, cool. Looks like we're getting somewhere with this. That's much better. Right. The last thing I'm going to teach you, this is going to cover today's lesson. It's going to cover tomorrow's, not tomorrow's, next week's lesson as well, because this is where really actually simultaneous equations become much more common. Is what happens if none of the letters match. Okay, so let's have an example. It's got 3x plus y equals 20. We've got 2x plus 2y equals, let's say, 18. All right. And I'm going to demonstrate this one, so get ready with your pen and pencil, whatever the hell you're writing with, to take full notes on this one, all right? So it's 3x plus y equals 20, 2x plus 2y equals 18. Okay, so here none of the letters cancel, all right? There's no easy way in. All the questions I've given you, I'm just going to wait for you people to log back on and see if people haven't logged back on again. Right, we've got everyone back, good. Okay, so I'm going to demonstrate this one now, so be ready to take notes. So here we've got a problem because none of the letters match. There's a 3x, a 2x, and they don't match, and y and a 2y, they don't match. What we do is we multiply one of the equations all the way to so they match. You can choose which letter to match. What I'm going to choose to use is I'm going to choose to make the y's match, all right? So let's call this guy equation 1, call this guy equation 2. I'm going to multiply equation 1 by 2, so it will now become 6x plus 2y equals 40, all right? So this is just literally just equation 1 multiplied by 2. And I'm allowed to do that as long as I multiply everything through by the same number. So I've now got 6x plus 2y equals 2. Notice I'm not multiplying the other equation by 2. That's not happening. I'm not multiplying the other equation by 2. I'm only multiplying one of the equations by 2 in order to make the y's cancel. All right, so I hope that makes sense so far. Just trying to give myself a little bit of space here. What I'm going to do now is just finish the equation as normal. So here I've got a plus 2y and a plus 2y, so I'm going to subtract them. I end up with 4x equals 22, and x equals, what would that be? 22 over 4, 11 over 2. Yeah? And obviously you can find y from there. You just substitute back in. So if you've got 11 over 2 for x, that's going to be 11 to 2y. So y would be, you don't have the 2y equals 7. So y equals 7 over 2. Those are your final answers, right? That's just doing the math that you're familiar with, just solving equations. What's the big thing that you've learned here? You've learned that if the letters don't match up, you can multiply through the entire equation to force them to match up, all right? Can you take notes on this? And then if there's any particular ones you didn't understand, can you write down in the chat box what you didn't understand? And I'll go through the equation again, showing you how it's done. Good. Right, so here's one for you to try. It's going to be a little easier. I'll make a nice little one for you. So here you've got x plus y equals... So x plus y equals 10. And you've got 2x plus 3y equals 24. And you can choose which letter you want to cancel out. I want you to try it for me and come back with a solution. If you're struggling, you pop in the chat box and I'll go through this one, okay? I'm not fully expecting you to get this the first time, but by the end of next week, you should fully understand it. Multiply the second line. You're definitely going to multiply the second line, yeah? Which letter are you going to choose to cancel, though? That's down to you. Are you going to choose to make it an x the same, or you choose to make the y the same? It's whatever you're more comfortable with. You're going to make x the same. Fair enough. It's a good show. So y equals 14 is the claim. I don't see it, but let's have a look. So you're going to cancel the x's, yeah? So you means you're going to multiply equation 2 by 2. So you've now got, the first equation stays the same, so 2x plus 3y is still 24. But the second equation is going to be 2x plus 2y equals 20. So I'm going to go, yeah, y equals 4. Y equals 4. I reckon Harris is right. So remember, you're multiplying everything in that second equation by 2, because if you want the 2x, you have to do all the other things for it. What about 20? Yeah, fair enough, fair enough. So if x equals 4, well, if y equals 4, how the hell is that x going to be 5? You've got x plus y equals 10 as your second equation, right? Come on. Common sense here. Obviously, something's got a little bit weird here. X equals 6. Now we're talking. Now you're talking. That's beautifully done. Well done. That's good progress. I'm happy with that. I'll do one more. And I'll set you homework. That's not been too bad. But remember, you need to keep recapping the stuff, right? So one of these days, we are going to get to the point where quadratics comes back as well. So quadratic simultaneous equations. So that's not next week, that's the week after. And when we do that, you need to know all your stuff. But so far today, half decent, not bad. All right, okay, let's have a look. So we come up with this guy, 3x plus 2y equals 27. X minus 4y. Actually, I allow 4y, so I don't even know how that's going to work. X minus y equals 0. So you can make an equation out of that. Actually, that's not possible to solve. Allow me. 2x minus y equals 0. So claim is y equals 27 over 4. Okay, so if you subtract, so what have you done? Have you done x or y? I mean, I'd probably cancel the y, so I'll do that. So that's equation 1, that's equation 2. Okay, this second one's going to get multiplied by 2. So you've got 3x plus 2y. Good shout is what you should do. I mean, that is the right shout there. This guy here is going to be 4x. You got minus 2y, just times by 2 equals 54. You cancelled x. How? Times by 1.5. I mean, you could, but like the y is the one to do. I mean, I'm not saying you're wrong. Just don't do it because your life's going to be difficult. Because now you can just add these and you can go 7x equals whatever the hell that is, 54. And just check I've got this right. Double up on that. That is right. That's 0, idiot. That's 0 there. Still 0. So you get 7x equals 27. X equals 27 over 7. Yeah, you got that right. So you got it. Harris got it right. 27 over 7. I disagree with you, Numan. I don't know where you got 4 from, for a start. I don't see 1x anywhere in this. I'm not going to lie to you. So what happens is you multiply this. Well, I don't know what you did, but y, first of all, y is the one to cancel. I'll show you how to cancel x later on, maybe next lesson, right? But for you, y is the one you should have picked. Okay, so you've miscopied. That's all it is. Okay, fine. All right, cool. I'm going to pop homework up. I'm just going to leave that there, actually. Finish the x's. I finished the question as well. X equals 27 over 7. Fine. That's not too bad. So that's 54 over... So that's 27 over 54 over 7 equals 0. So y... Yeah. Absolutely. So Harris is right. Good job. So when you finish copying, pop up something in the chat box so I can put the homework questions up. So as soon as you finish copying down, let me know and I'll pop your homework up. Done. Excellent. Right, so 3 questions. 3 questions. None I'm going to give you like this because I want to spend like the whole of next lesson on those kind of questions. I'll give you some easy ones. They were like the ones we've been doing before. So 2x plus 7y equals 20. 2x minus 2y equals, should go with 2 there. That's 1. Here's 3x plus 5y equals 12. X minus 5y. Should we go, yeah, x minus 5y. Let's see what happens if we'd add those together. So probably best idea to put that as a 4. That's your last one. Just to give you an idea of where we're going with all of this. Next week, we're going to carry on doing the things that you saw in the last 10 minutes. The week after that, quadratics are coming back with simultaneous linear and quadratic. All right. So that will be, shall we say, interesting. So make sure for in the next week or 2, start recapping that stuff again. So 2x plus 7, let's go 2x plus 5y equals 11. I'll give you some nice fractions to deal with. Okay, that's that done. As soon as you finish copying, drop out so I know you're finished. That's us done for today. Well done. That was half decent. It's playable at least. I mean, it wasn't bad. It wasn't bad. Okay, in that case, I will see you around. All right, take care. And that's